In this video, we're going to be looking at identifying trend sites. Now, the trend sites can be identified in a couple of ways. We might be looking at a particular region and doing some filtering. For more information, there's a whole video on that from the previous video. But we might also want to look at a particular data set. For example, the tracking data sets and the observation data sets might not mix quite as well for our sampling. If we want to map to a particular dataset, we need to know what dataset to actually extract and subfilter to. So we can do that here by looking at all of the datasets and plotting how many of them we have per dataset. This one at the top here, the Seabird Atlas, is pretty good and is actually our highest count of records. In terms of filtering to that dataset, it's similar to the Australian Marine Regions tags filtering. All we need to do is look where the dataset name is equal to the dataset that we actually want to look at. As before, all of our mapping code is identical, except for some of the aggregations that we do. But in this case, we've subsetted our data and the plotting to just the Seabird Atlas dataset. But this is an aggregated dataset product, so what if we want to look at which regions contain actual time series and maybe they're spread across different datasets? In this case, we're going to be aggregating at a slightly bigger hexagon size, so a lower resolution, number 4. But we're going to be adding the event date to our aggregation, and this lets us see where there are particular hexagons with more than 1 year of data in them. We can see here that our aggregate column name has been swapped out for the number of years rather than the number of records. This results in a bit of a different colouring, but you can see in many locations there are different data sets covering different years in the same locations. So if we zoom in the southeast region, many of these hexagons have multiple data sets and multiple years, so potential sites for trend analysis over time. As an added bonus here, we're going to also look at the wind farm regions. So bird and vessel traffic are significantly interesting in terms of their placement in relation to offshore wind farms, as they can have negative consequences. We thought we'd do a little bit of an addendum and add the offshore designated wind farm regions so we can see how these things might interact, the seabirds and the wind farms, if they are put in place. We're using some new utility functions here. At the top, we are generating a geodata frame from a shapefile. This shapefile is included in the repository, so you should be able to see it downloaded in that section. Firstly, we filtered this data frame to the declared regions where the wind farms are allowed to go. That's a simple filtering expression here. But next, we actually want to set up a different kind of PyDeck layer. In this case, we're going to be using the GeoJSON and creating regular polygons rather than H3 layer polygons. In this section, we are pre-filtering the entire dataset to only the marine regions where we know there's interaction with the designated offshore wind farm areas. Then we're generating a WKT H3 index representation of the declared regions of the wind farms. You can see more details in the utility functions video, but in principle what we're doing is allowing us to do a spatial join using H3 rather than complex and computationally expensive joins on the geometry itself. Finally, we do a regular aggregation and a generation of hexagon layers using our regular utility function. And when we plot everything together, we can see there are declared wind farm regions and some interaction with the tracking channels of the birds. So interestingly, most of these seem to align fairly nicely, although we can see there are some known locations of birds that do overlap the declared regions. Finally, we can use our generated H3 index representation to filter out all of the records which don't lie on a declared wind farm region. We see that in this case, we've managed to filter out everything to just the occurrences that occur overlapping with declared wind farm regions.